Hello. Today our topic is system security, assessment, normal, alert, emergency, extremist states of the power system. We are talking about the power system. So, power system security assessment, we are saying that it is an assessment of the operating network. We are operating in such a manner, so we have to identify whatever the positive failures which is occurring in the system and what are the consequences and what remedial actions we have to take. So the power system, we can assume that so power system, when we are talking, we are assuming that it is being operated under two sets of constraints. One is the load constraint and other is the operating constraint. So the load constraint, it imposes the requirement that the load demand must be met by the system, and the operating constant, it imposes the maximum or minimum operating limits on system variables, and that is associated with both steady state and stability limitations. So when we are talking in a mathematical way, so the load constraint can be expressed in the form of familiar load flow equations. The operating constants can be expressed in the form of inequalities, such as the equipment loading, bus voltage, phase shift differences, generator real and reactive power, etc. So the operating conditions of the power network, it can be categorized into three operating states. One is the normal, or we can express preventive state, then the emergency state, and the third one is the restorative state. So we are talking about three states, that the normal or preventive, then emergency, then restorative state, right? So here, what we are going to see, when a normal state is there, in the system, we are saying it's a normal state when the load and the operating constants are satisfied. Two constants, that is the load, and other one is the operating constant. It has to be satisfied. So it is reasonable that we are assuming that the normal state of the power system is a quasi steady state condition, and for the given time the interaction of the load constraint and the operating constraint, because two constants are there, so whatever the interaction of the intersection of load constant and the operating constants, it will define the space of all feasible normal operating states. The power system, it can be operated anywhere in the space. So when we are talking about the normal operating point, it can be classified as either being either secure or insecure, and we are taking with reference to the arbitrary set of disturbances or contingencies. So normal state is said to be secure when at the secure operating point, if it undergo any contingency in the next contingency set, and without getting it to the emergency condition. And when we are taking on the other hand, if at least or least one contingency in the next contingency set, which will bring about an emergency in the normal system, we are calling it say alert state. So then a system in the emergency state, right? Here the operating constants are not completely satisfied. So whatever the constant we are taking at the operating stage, it's not satisfied. So two types of emergency we can take. One is when only steady state operating constants are being violated. So example, an equipment loading limit when it is exceeding, or the voltage at a bus below a given level. So the other we are taking when the stability operating constant is violated, and as a result of that, the system cannot maintain stability. So first type of emergency we are saying it's a steady state emergency, and the second type, that is the dynamic emergency. So the third one is the restorative state. So here the load constraints are not completely satisfied. So this means that either or a total system shutdown or extreme emergency or extremist state, which will comes into play. There is occurrence of extreme major disturbance. So in this case, what the power system is able is stable is a stable state and may lead to the shutting down of the major parts of the power control system. So that is the restorative state. So then we have a contingency analysis, right? We have a preventive control, contingency analysis, preventing control, and uh, uh, emergency control also. So when we are talking about the power system, so for a secure operation of the power system, so it may have the continuity in supply without a loss of load. The supply will be continuous. So this for this security analysis, we are taking or performing to develop various control strategies, and we guarantee that the avoidance or the survival of emergency conditions, and to operate the system at a lowest speed. So whenever a pre-specified operating limits of a power system, when it gets violated, so the system is said to be in emergency conditions. So the violation of whatever the limit, it results the contingencies of the in the system. So contingency, when we are talking, it's an unexpected failure of transmission line. So transmission line fails, or the transformer or the generator, it fails. So usually the contingency will occur due to the fault, short circuit, or to one of these components. So such when such fault occur, the protection systems will sense the fault and remove the component. So this is also fault from the system. For example, if we are taking some remaining circuit may be overload, or a bus may experience a over voltage condition. So this is when we are talking, this is a static security problem. And dynamic security problem, it can also be occur. It includes the uncontrollable controllable voltage decline will be there, generator over speed, or it will be loss of synchronism, or undamped oscillatory conditions. So contingency techniques are also used to predict the effect of outages, like failures of the equipment, a transmission line, and to take, we are taking necessary action to keep the power system secure and reliable. So contingency, if we are talking, we are dividing into 5 different categories. That is the contingency definition, then selection, then evaluation. So three different categories. So first is the contingency definition. So when we are taking contingency, it is a set of contingencies that will occur in the power system. Then we have selection. So we are identifying whatever the contingency that actually leads to the violation of the operation limits. So which is known as the contingency selection. So this is the process. In this process, it will remove the unimportant contingency and make the contingency list is shortened. Right. Then we have to evaluate it. Evaluation is there when we are talking about evaluation. So in this process, it involves a necessary security action or the action to function in order to remove effect of contingency. And whatever the preventive control and emergency control methods we are adopting, so one is the security analysis. Security, it will determine whatever the normal system is secure or it is insecure. The second function is to determine the corrective action strategy we are taking when system is insecure. So first, when we are talking about first function, so it commonly it classify under contingency definition, selection by definition. So security of the system is determined with the reference to the set of next contingency. Second part we are taking in the security analysis is the corrective action strategy. So here, whether the system would respond in an acceptable manner and reach the acceptable state, one of the predefined contingency set. So here, there is, if a system is insecure, can it be made secure? How and what cost? What are the conditions we are imposing over there? So suppose the system is now insecure. So there is no way of making it secure. How much load would we are shutting down? Then preventive control, it is a system operator that infers the operating data that the system in the alert state. So preventive control actions should take into back to the normal state. So in the state of normal, when the system, then the system operator, he will wish to do minor changes in the real and reactive scheduling. So from the perspective, economic perspective point of view. So if the flexibility occurs over there, so whatever the change, such a change cannot bring the system out of secure system. So system is not secure or alert. Then the operator, what he will do, he has to try to steer it from the secure state by real and reactive power rescheduling. Then we have emergency control. In emergency, if a system infers, operator infers from the operating data that the system is in the alert state, then he will take preventive control actions to bring the system back to the normal state. So, however, it is possible for the system operator is unable to act in time before the contingency actually occurs in the grid, or may even operate insecurity in the alert state due to the high cost of preventive control. So some emergency controls when we are talking actions, what we are taking over there, that is the control of generation. We are reducing or increasing as per requirement, and then we have to trip off generation or load scheduling, then control of voltage and rerouting of power flow, how it is flowing. So one thing which will come in our mind, that is corrective rescheduling, right? So when we are talking about the corrective rescheduling, so here, when we are talking about corrective rescheduling, what does it mean? So basically, it will measure whatever the basically defined as whatever the measures we are taking to avoid the fault after it is occurred. So it is to isolate the defective fault from the non-faulty part of the power system and then further rectify the fault. So when we rectifying the fault, so after rectification, the fault in the power system, it is then restored in the power system from where it is violated. So this is all about the emergency control, preventive control, contingency analysis techniques, right? So whatever the contingency analysis, preventing control, and the emergency control is there. Thank you very much.